Hello students, welcome to BSR Chemistry channel guys. In this video, we will discuss one of the general organic chemistry topic that is nothing but classification of reagents. Classification of reagents. If you consider a reaction, X plus Y reacts together and gives Z. X plus Y are called reactants. Z is called product. Z is called a product guys. So now reactant is two category. The first one is substrate. The first one is what? Substrate. Second one is called a reagent. So reactant is divided into two category guys. First one is what? Substrate. Second one is what? Reagent guys. Substrate is nothing but main reactant. Main reactant. Attacking species is called reagent. What guys? Attacking species is called reagent. Actually, the main reactant in that organic reaction is always organic compound. And the attacking species or reagent is generally nothing but inorganic species. Organic compound in that reactant as maybe polar or maybe non-polar. Maybe polar or non-polar. But that attacking species is always polar only. If you look here, the topic name is classification of reagents. If you consider reaction between X plus Y and this gives Z. X plus Y is called as reactants and Z is nothing but a product. Reactants are two category guys. There may be substrate and another one is a reagent. So substrate is a substance which one is a main reactant. It must be organic compound. It may be polar or a non-polar. Reagent is a attacking species. It must be inorganic and must be polar compound guys. Now move to reagent category. Reagents are two category. One is electrophile. One is what? Electrophile. Another one is guys nucleophile. One is electrophile. Another one is a nucleophile. Before telling about electrophile, how to consider one example. If you take CH3, CO, CH3, when it reacts with Cn minus. Now here oxygen is a more electronegative element. So why it will get partial negative charge and carbon will get partial positive charge. Now this Cn minus is there now, so it will attack on positive carbon. So Cn attacks on this acetone compound now, so means this is attacking species, simply called as what? Reagent. And here carbon containing this compound is called substrate. What guys? Substrate. Like that we can divide. Again reagents are two types now, electrophile, nucleophile. Now move to electrophile. Electrophile means electron loving, means it ready to accept electron guys. And also electrophile means electron deficient. Electron deficient. So means it ready to accept electron. One who accept electron, that one is called Lewis acid. That one is called Lewis acid. Here A plus ready to accept an electron means A plus considered as a Lewis acid guys. How to find electrophiles? In first case, if central atom has less than 8 electrons in its valence cell, those species can act as electrophiles. For example, if you take BeCl2, here beryllium is a second group element, so there are two valence electrons. So means that beryllium bonded with chlorine now. So by sharing of electrons, it can share electron with one beryllium valence electron with another beryllium valence electron. Now there are 4 electrons present in that beryllium valence cell. Means it is 4 electrons shorter than octet now. Means it ready to accept 4 electrons. Means 2 pairs. So it is electron loving. Means this one is considered as electrophile guys. Like that if you take BX3, maybe BF3, maybe BBR3, maybe BI3, maybe BCl3, whatever we can take. So boron group is a third. It contains 3 valence electrons. So these 3 valence electrons are shared with 3 halogens, means in valency cell there are 6 electrons, means 3 pairs of electrons are there, means it ready to accept another pair of electron to become octet. So it is also electron deficient, so it can accept electron pair and act as a Lewis acid, guys. For example, if you take AlCl3, so aluminum is also third group element, 1, 2, 3. So 1, 2, 3, it share with the 3 chlorine atoms and it contains 6 electrons. So means also it can accept a pair of electron and act as a electrophile, guys. Now move to second category. Positively charged species act as a electrophiles, guys. For example, CH3 plus means electron less. CH3 plus, C2H5 plus, X plus, halogen plus, HSO3 plus, so NO2 plus, NO plus, or CO plus, these all are ETC. These all are electron deficient, means they can accept electrons from someone and act as electrophiles. Electrophiles. In case of third one, pi bonded molecules in which electronegativity of surrounding atom is more than central atom. Here electronegativity of surrounding atom is more than central atom and that molecule contains pi bond, those act as electrophiles, guys. For example, if you take CO2, carbon dioxide, we can write that one as C double bond O na. Here there are 2 pi bonds and carbon is bind with oxygen na. Oxygen is more electronegative than carbon. In such case, this one act as a electrophile, guys. For example, SO3. Here we can write that one as S double bond O, S double bond O, S double bond O na. In that case, oxygen has more electronegativity than sulfur and also it contains pi bond na. So means it act as a electrophiles. Like that, SO2. Here also we can write S double bond O na, means here this one is also act as a electrophile, guys. The fourth category, species in which central atom has vacant d orbital. Those also can act as electrophiles, guys. For example, if you take FeCl3, iron is a d block element and it has vacant d orbital, so it ready to accept electron pair and act as a electrophile, guys, and act as a electrophile. So for example, if you take SnCl2, Sn, tin. So after second period, all elements contain vacant d orbitals na. So means those molecules are ready to accept electrons and act as electrophiles, guys. SnCl2 act as a electrophile. Like that, if you take PCl5, it can accept electron pair from Clc minus, then it will become PCl6 minus, guys. Here P phosphorus is a third period element. It has vacant d orbital, so means it can accept pair of electron and act as a electrophile, guys. For example, SF4, so it may change into SF6 by accepting pair of electrons because it contains vacant d orbitals. For example, if you take AlCl3, it accepts a pair of electron from the chlorine and can become AlCl4 minus. So it accepts a pair of electron due to presence of vacant d orbital and act as electrophile. And also it is electron deficient compound. If you take SiCl4, silicon is a third period element and also it contains vacant d orbital. So it accepts pair of electron from the water and involved in hydrolysis. So this one act as electrophile. So like that we classify reagents as electrophiles, guys. So here I want to revise. Electrophile means electron loving or electron deficient. So who accept electron pair act as Lewis acid, guys. Who can act as electrophiles? In step 1, one who has less electrons than octet in their valence cell, they can accept a pair of electrons. And like that example we discussed. In second case, Positively charged species means electron deficient. So they also can accept pair of electron and act as electrophiles. In third case, who are with pi bond and in such case, if electronegativity of the central atom is less than the other atoms, for example, like that carbon has less electronegativity than oxygen and that molecule has a double bond, pi bond, so that one act as electrophile. In third case, the species who are with vacant d orbitals, except first period and second period, those can ready to accept pair of electron and act as a Lewis acid, guys. I hope you understand about electrophile. In that reagent category, second one is nucleophile. I want to move to nucleophile. Nucleophile means nucleus loving. Nucleus loving. And electron pair donors. Electron pair donors. Who can donate electron pair? They are called Lewis base. They are called Lewis base, guys. They are nucleus loving and electron pair donors. They are simply called nucleophiles, guys. Then how we can find a nucleophile? Follow me. In case 1, negatively charged species act as nucleophiles, guys. Act as nucleophiles, guys. For example, if you take OH minus, Cl minus, Br minus, F minus, X minus, Cn minus, RO minus. So here RO minus means alkyl, CH3O minus, C2H5O minus, like that. If you don't know about alkyl group, I already made a video on that alkyl group, how to watch that, guys. Then ETC. Second category, central atom at least with one LP, one lone pair can act as a nucleophile, guys. For example, how to take NH3. Here if you take the nitrogen group number 5, now 1, 2, 3, 4, 5. Here 1, 2, 3 hydrogen bonds are there. Then remaining one is called lone pair. So here NH3 contain one pair of electron. So NH3 can donate pair of electron to electron deficient or electrophile and can make a bond like this. So NH3 donate a pair of electron means it act as a nucleophile. Not only NH3, H2O, there 2 lone pairs are there. You can find based on the hybridization. How to find hybridization and number of lone pairs. Already I made a video on the topic how to watch that. If you are not able to understand how to find lone pair of electrons and hybridization. H2O has 2 lone pairs, so it acts as a nucleophile. For example, if you remove hydrogens and add alkyl groups like that, ROH, alcohol, both alkyl groups, ROR, ether, these are also nucleophiles. For example, if you take NH3, if you replace hydrogens with R group, so RNH2, 2 R's, R2NH, then R3N. For example, oxygen is a 6th group element, sulfur is also 6th group element. So if you take R2S, H2S, these all are with pairs of electron. So means they can donate their pair of electron and they can act as nucleophiles, guys. Organometallic compounds act as nucleophiles, guys. What is meant by organometallic compound? If a carbon linked with metal, those compounds are called organometallic compounds. For example, RMgX, Grignard reagent we call. So always metals bear with positive charge. That's why it can divide as R minus Mgx plus. Like that R2CuLi, that can divide as 2R minus Cu plus and Li plus, guys. For example, RLi, so it can divide as R minus plus Li plus. Like that they can divide. These all cases, carbon bind with metal, those compounds are called organometallic compounds. In such case, carbon divided with negative charge and act as nucleophiles, guys. Pi bond containing carbon molecules. For example, CH2 double bond CH2. Alkene CH triple bond CH. alkyne na. So now have to take a 6-member ring with 3 double bonds, a 5-member ring with 1 double bond. Like this, pi bond containing hydrocarbons, particularly carbon molecules, can act as nucleophiles, guys. In before case, if central atom has less electronegativity than other atoms and with pi bonds, they act as electrophiles, I said. Here, carbon compounds, hydrocarbon with double bond and triple bond or whatever that pi bond, they act as nucleophiles, guys. So, like that we can identify nucleophiles. Here simply the topic name is classification of reagents. Reagents, nothing but reactants are 2 categories. Substrate, reagent. Main reactant is called substrate. Attacking species is called reagent. Then that attacking species reagent again divided into 2 categories. Electrophile, nucleophile. So electron loving are called electrophiles. For finding electrophiles there are different categories. So central atom has less than 8 electron electrophile, and positively charged species are electrophiles, and pi bonded molecules where central atom has lesser electronegativity also act as electrophiles, and species who are with vacant d orbitals also act as electrophiles, and nucleophiles means nucleus loving electron pair donors, and who are with negative charge are nucleophiles, and central atom has at least one lone pair act as nucleophiles, and organometallic compounds act as nucleophiles, and also pi bond containing carbon molecules also act as nucleophiles, guys. Now move to certain questions. Okay, look here, how to take these examples. First, it is a positive charged species, so means it can accept electrons, so it act as electrophile. If you take second category, nitrogen is central atom na, so 1, 2, 3, 4, 5 electrons. Here 2 hydrogen bonds are there, 1 alkyl bond is there, have to strike that. Then remaining 1 pair is there, 1 lone pair is there, means it act as nucleophile. Then have to take pH3, phosphorus group number 5 na, 1, 2, 3, 4, 5. There are 3 hydrogen bonds, 1, 2, 3, remaining pair na, pair is there, it act as nucleophile. Now in case of H2S, there are 2 pairs of electrons, so it acts as nucleophile. Now if you take a PPH3, in case of PH3, phosphorus 1, 2, 3, 4, 5, there are 3 PH3 bonds, there is a 1 lone pair, so it acts as nucleophile. Now there is a pi bond between carbon and carbon, so it acts as pi donor, and it also acts as nucleophile. Here also there is a double bond, pi bond, act as nucleophile. There that is a negative charged species now, also act as nucleophile. Now I have to take BH3, boron 1, 2, 3, third group, there are 3 hydrogen bonds, 1, 2, 3. Now it have no lone pair of electron, and also it has only 6 electrons in valency shell, so it accept electrons, so it act as electrophile. H plus, it have no any electrons, so it ready to accept pair of electron, so it act as electrophile, guys. So like that we can identify electrophile or a nucleophile. Now one special case, that is ambident nucleophile. So nucleophile is an electron pair donor na. So here ambident nucleophile means a nucleophile with more than one donating atoms, that one is called ambident nucleophile. Cn minus and Nc minus if you take. Here carbon can donate pair of electron, and also nitrogen can donate pair of electron. Both atoms has possibility to donate pair of electron. So the type of nucleophiles are called ambident nucleophile. So one who bear with more electronegativity, that has least donating nature, guys. For example, in case of Cn minus, if carbon with negative charge, and Nc minus nitrogen with negative charge, electronegativity of nitrogen is more than carbon. So Cn minus carbon can donate easily than Nc minus, guys. So like that we can write the remaining also NO2 minus, ONO minus, SCN minus, SNC minus. Like that in these all cases, more than one donating atoms are there. Those are called ambident nucleophiles, guys. I hope in this general organic chemistry class you understand about two categories of reagents, electrophile and nucleophile. If you learned something from my video, just like this video, just subscribe for more videos guys.